Hello, I'm discussing about Alkane under base first year. First of all, definition of alkane. Alkanes are organic compounds that consist of single bonded carbon and hydrogen atoms. The formula for alkane is CnH2n plus 2. Energetics of reaction, the energy changes during chemical reaction is simply known as energetics of reaction. The bond between reactants molecules dissociate and new bond is formed during the chemical reaction. So energy required to dissociate bond is called bond dissociating energy into isolated atom. Energetics of chemical reaction, every reactant will have a discrete amount of energy. Rearrangement of atoms that occurs in a chemical reaction is virtually always accompanied by the liberation of absorption of heat. Bonds are broken in reactants and bonds are formed in the products. Exothermic reaction, heat is given off, that is, heat is produced. As a result of this release of heat energy from the system, reactants, the surrounding will have increased the temperature. Energy of reactant is lesser than the energy of the surroundings. So what happens after the heat energy is being released? Products form will have energy level lower than reactants. So conservation of energy. Exothermic reaction, example of exothermic reaction, carbon combusts, that is combustion under the presence of oxygen to produce carbon dioxide. Neutralization between an acid and alkali. Granular zinc with tin oxide chloride metal displacement reaction. Endothermic reaction, heat energy is taken in the system. Reactants take energy from the surroundings. Surrounding loses heat to the reactants. Energy of reactants is greater than energy of the surrounding. So what happens after heat energy is being absorbed? Product form will have a higher energy than the reactants. Conservation of energy. Examples: thermal decomposition, heat is hydrated carbon, copper sulfate, anhydrous copper sulfate. Photosynthesis. Enthalpy is also known as heat contained, is the total energy of system, sometimes of which is stored as chemical potential energy inside the chemical bonding. Absolute enthalpies of particular states cannot be measured, but change in enthalpy that occurs during the reaction can be measured using calorimetry. Delta S is positive for endothermic reaction. Heat energy is gained by the system from the surroundings, hence the surrounding will dip in temperature. Delta S is negative for exothermic reaction. Heat energy is lost to the surroundings and cause the temperature in the surrounding to rise. For endothermic reaction, final products have a higher energy than the reactants. For exothermic reaction, final products have a lower energy than the reactants. Bond energy, covalent bond exists in covalent compounds. Those covalent bonds have a specific amount of energy to hold the atoms together. This energy is called bond energy. Energy is absorbed during the bond breaking and energy is released during bond forming. Why do we need to study the chemical energetics? It can lead us to understand a chemical change better. For example, what is the temperature for a reaction to occur? It will also tell us the energy of barrier that reactants have to overcome before becoming the products. Energy profile diagram, the graphical representation of energy change of chemical reaction is called energy profile diagram. Let us consider a simple reaction in which reactant molecules yield product in single step. A chemical reaction held by the collision of reactant molecules where energy is provided in the form of heat, light, or by kinetic motion of molecules, which increases the energy of the system by changing kinetic energy into potential energy at the time of collision. Reactants activation energy enthalpy change the products. Threshold energy, the reactant molecules must be associated with a certain minimum amount of energy called threshold energy. Activation energy, the minimum amount of energy that system must observe to reach the transition state is known as activation energy. Transition state, the state in which no further absorption of energy and molecule do not have true bond, which is called transition state, and reactant is called activated complex. For example, A is reactant and B is activated complex and C is product. Types of reaction: endothermic reaction, reaction in which heat is absorbed from surrounding by reaction system and known as endothermic reaction. Delta is change in enthalpy. Delta is product minus delta S of reactants. So delta S product is greater than delta S reactants. So delta S product is positive. Exothermic reaction, such type of reaction in which heat is evolved out of the system. Delta S product minus delta S reactants, where delta S product is lesser than delta S reactant. So delta S product is negative. Types of energy profile diagram. Exothermic reaction, single step reaction. This is the single step energy profile diagram. This is the double step exothermic reaction. Exothermic triple step, three-step reaction. Endothermic single step. Endothermic two-step. Chemical formula, it is the combination of symbols used to express the chemical components of substance. For example, molecular formula of glucose is C6 as 12O6. The empirical formula is CS2, that is the chemical formula that expresses proportion of elements present in the substance. Molecular formula, a chemical formula that expressing the number of each element present in substance without indicating how they are linked. For example, glucose. Spatial or stereochemical formula, chemical formula giving the number of atoms of each element present in a molecule of a substance, which atom is linked to which. This type of linkage involves the relative position of atoms in the space. For example, the chlorine and bromine, the bond, the plane toward the observer, and this hydroxyl group and fluorine to the carbon, both between the plane away from the observer. Fisher projection formula, a plane of projection formula, three-dimensional molecular model obtained by drawing the main chain in the vertical arrangement and other groups of the other sides of the chain so that vertically are considered to be below and behind, and the projection plane are horizontal bones above in front of the plane. This is the Fisher projection formula. The main chain is written in the vertical line and side chain in the horizontal line. These are the Fisher projection formula. Newman projection formula are a way of drawing the conformation. Front carbon atom is represented by three lines, three bonds coming together in Y shape. The back carbon is represented by circle with three bonds pointing out it, and these bonds again come together in form of incomplete Y. The molecules viewed along the axis of the given bond. See, this is the molecule of the ethane. This is the Newman projection formula. This is the front carbon, and this incomplete Y that is circle is the back carbon. These are the Newman projection formulas. This is the fully eclipse. The bulky groups are near. Gauss, that is the difference between 60 degree between the bulky groups. Eclipse, it is the small and bulky groups are near, and anti, this is the 180, the bulky groups. Sauer's formula, a perspective formula indicating the spatial arrangement of bonds on two adjacent carbon atoms. The bond between the two atoms is represented by diagonal line, the left-handed bottom which locates the atom nearer the observer, and the right-handed top in the atom that is further away. This is another alternative to representation by the wedge and dash model. The name of this projection comes from the similarity that the drawings of the molecules show with the Carpenter's softwares. This way of representing the molecules has the proof of observing the bond formed by carbons in organic molecules and allows a 3D perspective of the molecules drawn on the paper to be obtained. This is the Sahour's formula. This is the Newman projection formula. This is the Sahour's formula of the ethane. This is the eclipse form, the staggered form. Chiral center is defined as an atom in a molecule that is bonded to 4 different chemical species and allowed optical isomerism. Example, central carbon is serine is chiral carbon. The amino group and hydrogen rotate about the carbon. This is the example of chirality amino acids using hands to illustrate how the molecules are mirror images of each other. Conformation, the different structures which resolve by rotation about a single bond are called conformation. The different arrangement of atoms with respect to each other due to carbon-carbon sigma bond rotation are called conformation. See the rotation of this carbon, again rotation, Newman projection formula of ethene. Configuration, the arrangement of atoms in space of a molecule of defined constitution without regard to arrangement that differ only as after rotation about one or more single bonds is called configuration. The arrangement of atoms in a space of a molecule of defined constitution without regard to arrangement that differ only as after rotation about one or more single bonds. Absolute configuration. We use absolute configuration for chiral molecules in stereochemistry to describe 3D orientation of the molecule. The absolute configuration of a molecule refers to the spatial arrangement of atoms around a chirality center. R and S are the terms used to refer to the absolute configuration of molecules. Absolute configuration refers to the actual arrangement of atoms in space. Relative configuration refers to the correlative configuration, that is relative configuration relative to configuration of one compound with other. This is the Fisher projection formula. Eclipse, Newman, staggered Newman, and staggered Sahour's projection formula. Conformation of butane. In butane, there are three carbon-carbon bonds possible for rotation. Among these three carbon-carbon bonds between C2 and C3 is considered as the bond having center of gravity. It has following different conformations. Steric strain, it is repulsive interaction between methyl groups of carbons that are not neighboring. So it is electron-electron repulsion of methyl groups which reach close each other. If the distance between the groups or atoms is just equal to the sum of their van der Waals radii, there will be the attractive interaction. When these groups comes closer, then this distance they repulse each other to create a steric or van der Waals strain. Torsional strain, it is the destabilization of an eclipse conformation leading to that of staggered conformation. The energy required to rotate the molecule around the carbon-carbon bond is known as torsional energy. There is tendency as part of their carbons linked to each other to have a staggered, which is most stable because it has least torsional energy, and eclipse have highest torsional energy. Steric strain is the repulsion between two atoms or groups of atoms when the distance between them decreases. Torsional strain is the repulsion that arises between the atoms or groups of atoms when the molecule is rotated around the sigma bond. Cannot be lessened by rotating the molecules around the sigma bond. Can be lessened by rotating the molecules around a sigma bond. Occurs when the distance between the bulky groups of the molecule is decreased. Occurs when the bond electrons pass by each other when the molecule is rotating. Torsional strain. When the two large groups are eclipsed, that is both torsional and steric strain. Conformation of ethane according to Newman projection of carbon atom is observed and located center. The bond attached with their carbon atom is shown as a line from the center with 120 degrees separation. Other bond with adjustment carbon atoms are shown as line from the circumference as shown below. When an ethane molecule rotates about its carbon-carbon single bond, two extreme conformations can be resolved. The staggered and eclipse conformation will use Newman projection to discuss the conformation, staggered and eclipse. Preparation of alkane from Grignard using any class of reagent with the general formula, and that is the Grignard reagent RMGX, in which the R is the organic radical. Example, R is the alkyl or aryl and X is the halogen. These reagents react with great variety of compounds and are used in the synthesis of organic compounds. See, this is the ethyl bromide and reacts with the magnesium in dry ether to produce ethyl magnesium bromide. That is the Grignard reagent, and this Grignard reacts with water, it produces alkane ethane. In case of mechanism, in the case of ethyl magnesium iodide, the electronegativity of carbon and magnesium have the magnesium is electropositive metal, so it is the positive charge. So definitely electronegativity of carbon is higher than this magnesium, so it is the partially delta minus. When reacts with the, this Grignard reagent with water, In case of water, the hydrogen have the electropositivity and oxygen electronegativity. So this carbon attacks to this hydrogen, and this hydrogen oxygen electron is attracted by this oxygen and forms ethane. These all reactions are in the same mechanism as I discussed in above in the ethyl magnesium iodide in water. By Wood's reaction, the synthesis of alkanes is increased when alkyl halide, particularly bromide and iodide, is treated with the metallic sodium in the presence of dry ether. Mechanism of Wood's reaction, this is the alkane. When haloalkane is reacted with the sodium at a single electron transfer. See, the sodium one electron is transferred to this alkyl group, and this is the free radical. And again, one electron transferred is alkyl, and this compound is forms. And this negatively charged carbon attacks another halogen, alkyl halide. In this case, the SN2 mechanism forms. The negatively charged attacks to this carbon and releases this halogen and forms this alkane. This is the SN2 mechanism. You will discuss all detail about the SN2 and SN1 reaction in alkyl halide in the later on in the chapter. See, this is the bromoethane and reacts with the alkyl bromoethane in presence of sodium, produces the ethane. Decarboxylation, D means removal and carboxylation means carbon dioxide. The removal of carbon dioxide from carboxylic acid in presence of sodium hydroxide produces sodium ethanoate and water. This sodium ethanoate is the electrolysis and produces ethane. Mechanism of cold reaction, the cold reaction electrolysis produces ethane. In case of mechanism, oxidation of carboxylic ion on the anode and cathode process, the decarbonization and methyl free radical, which combine and produces the ethane. In case of mechanism, we discuss about this two free radical. This is the one single electron, and then this single electron forms the covalent bond and produces the ethane. By coupling alkyl halides with the dialkyl lithium copper Gilman's reagent, this is the haloalkane alkyl halide reacts with the Gilman reagent and produces triorganocopper intermediate, reductive elimination, and producing coupling product. Physical properties of alkane, physical state C1 to C4, member of the alkane are gas at room temperature. The next 13 members are liquid and other higher members are solid. Boiling point, greater the surface area of the alkane, greater will be the van der Waals force of attraction, and as a consequence, higher is boiling point. Branching makes the molecules condense and have lesser surface area and weak van der Waals force of attraction and leads the lesser boiling point. See in pentane, isopentane and neopentane, the boiling point of the neopentane is the N-pentane is the highest and least one is the neopentane. This is the graph shows the boiling point of alkane, melting point. Melting point of alkane do not show the smooth variation with the increasing molecular size due to zigzag nature of the carbon chain. Since alkane with even number of carbon chain is more symmetrical than odd number of carbon, Hence, even number of carbon chain can remain more completely than the odd number carbon chain in solid form. Therefore, on moving from odd to even and even to odd, non-uniform variation of melting point is observed. Density of alkane. The density of alkane increases with increase with alkanes reacts with halogen, chlorine, bromine. With heat or light, hydrogen atoms of the alkane is replaced by halogen atoms and alkyl halide is produced as product. This can be generally shown as the molecular weight not exceed 0.8 gram per cc. Chemical properties of alkane, halogenation, that is the halogen addition of alkane. When alkane reacts with the halogen, chlorine or bromine with heat or light, hydrogen atoms of the alkane is replaced by the halogen atom and alkyl halide is produced as the product. This can be generally shown as mechanism of halogenation. The mechanism of halogenation occurs in three steps: chain initiation, chain propagation, and chain termination. Initial step, the chlorine-chlorine bond of chemical chlorine undergoes homolysis. Uh, that is the free radical produces irradiate the UV light and this process yields produces the two chlorine atoms also called chlorine free radical. See in this chlorine and ultraviolet, this is the chlorine free radical. Propagation step, a chlorine radical abstracts a hydrogen atom from the methane to produce the methyl radical. The methyl radical in turn abstracts a chlorine atom from a chlorine molecule and chloromethane is formed. The second step of propagation also regenerates a chlorine atom. These steps repeat many times until the termination occurs. Methyl radical and this methyl radical again attached to chlorine and chloromethane. Termination takes place when a chlorine atom reacts with the another chlorine atom to generate chlorine or chlorine atom can react with the methyl radical to form chloromethane, which constitutes a minor pathway by which the product is made. The methyl radical can also combine to produce the ethane and very minor byproduct of this reaction. The reaction does not stop at this step, however, because the chlorinated methane product can react with the additional chlorine to produce polychlorinated products. See in this example, first the initiation and this is propagation and this termination. Orientation of halogenation to know which one of the product is formed predominantly of forming the more than one products and the chemical reaction is called orientation. Propane reacts with chlorine and 1 propane is the 45% and 2 propane is the 55%. The rate of extraction of hydrogen atoms is always found in the flow of the sequence 3 degree, 2 degree, and 1 degree at a room temperature. The relative rates by hydrogen is the 5 degree, 3.8, and 1. So 1 chloropropane, 2 chloropropane, number of hydrogen 1 degree, number of hydrogen 2 degree, reactivity of 1 degree hydrogen, reactivity of 2 degree hydrogen. So 6 over 2 into 1 over 3.8 equal to 3 over 3.8. So that is the 45 and 55%. Relative reactivities of alkanes toward halogenation. When the limited amount of chlorine was supplied to equimolar methane and ethane, which chlorine was formed 400 times greater than the methyl chloride, equivalent of mixture of chlorine, methyl chloride and ethyl chloride 400 times. The relative reactivities of alkanes toward halogenation, higher the electronegativity of halogen, higher is the reactivity toward halogenation. Reactivity and selectivity of halogenation, more stable, less reactive, and more selective. The trans state is more fully developed, that is, the reagent is less reactive, so chlorine is more reactive than bromine. Ease of extraction of hydrogen, it is the controlling step in halogenation, the relative ease of which the different cases of hydrogen atoms are extracted. The difference rate of extraction among the primary, secondary, and tertiary hydrogens are due to differences in activation energy, homolytic bond and dissociation energy and stability of free radicals, structure of free radicals. According to the quantum mechanics, carbon atom is free radicals, sp2 hybridized, that is the 1s orbital combined with the 2p orbitals from the carbon atom giving the 3 sp2 hybridized orbitals. The remaining unhybridized p orbitals uses above and below the plane of the free radicals with a single step. This is the structure of free radicals. Rearrangement of free radicals, the migratory groups moves with the just one electron is known as the free radical rearrangement. Transstate of halogenation, it represents the old bonds are partially broken and new bonds are partially formed. Hence, the trans state of reaction is the highest potential energy acquired by reactants during their change into products. So, trans state is unstable due to energy content and cannot be ionized. Concept of transit state helps to explain the differences in the rates of halogenation of alkanes. A more stable radical is associated with the low activation energy for its formation. Transit state leading to its formation would be more stable. The transit state of the abstraction of hydrogen atoms from an alkane is represented by S below. Is the yellow alkane in transition acquiring alkyl free radicals. Depending upon the extent to which the carbon hydrogen bond is broken in alkyl groups is associated with the characters of free radicals, it will form factors that stabilize the resulting free radicals. Delocalization of odd electrons tends to stable nascent free radicals in transition state. Combustion. When carbon and alkanes bond in air, they are the completely oxidized carbon dioxide and amount of energy. The above process is known as the combustion and exothermic reaction. The large quantity of heat is evolved and the source is expensive. So the petrol, diesel, kerosene, etc. Physical properties, the thermal decomposition of compound in is known as the pyrolysis, that is the heat. Appearance and ozone depletion. Appearance are the halogenations, that is the halogen derivatives of saturated hydrocarbons. So the fuels are is organic compounds containing fluorine, carbon, and the sum of these chlorine are bromine. It is the flammable, non-toxic. They have the low melting points, which makes them useful as refrigerants. Various evidence has accumulated by the decomposition of chlorofluorocarbons in the stratosphere, destroys the ozone layer. So it banned in the most of use international agreements signed that the most of the industrial countries have the whole phasing out of the chlorofluorocarbons. Okay, it's all about the okay. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. That's now bye bye. Okay. Thanks for watching and thank you for patience. That is now bye bye. See you again.